Hi, everyone, and welcome back. This is part two of our Law of Science video. We covered most of the content in the first part. In this part, I just want to cover two problems. Let's do a couple of word problems. In the first part of the video, we did some problems, but no word problems. So it's always a good idea to put what we cover into context. All right, so let's look at this one here. Two fire lookout stations are 17 miles apart, with Station B directly east of Station A. Both stations spot a fire. The bearing from the fire of the fire from Station A is north, 35 degrees east. And the bearing of the fire from Station B is north 30 degrees west. How far to the nearest tenth of a mile is the fire from each lookout station? Well, after reading through this once, you may or may not have an idea of how to go and solve the problem, right? But if you don't, that's okay, right? Let's just start with what we know, right? A diagram, like a picture, goes a long way. So if you're not sure, let's just say, for instance, you're not sure how to solve the problem, let's just start by sketching it out. Take what we know and put it down on paper. Okay. So we have two fire lookout stations are 17 miles apart. Let's start with that. Let's start with that. So we've got a lookout station right here. We've got another lookout station right here. And they are 17 miles apart. Okay. So far, so good. Now, next, with Station B directly east of Station A. Okay, so Station B is to the east. All right, so we're talking about directions. North, south, east, and west. So let's just make sure we know our compass headings. All right, we got north and south, up, down, and we got east, west is left, right. All right, so on the paper, east is to the right, west is to the left. North is up, south is down. So Station B is directly east. So that means Station B is to the right. So we'll call that Station B, and we'll call this Station A. Okay, so far, we're doing good. Both stations spot a fire. The bearing of the fire from Station A is north 35 degrees east. All right, so now we have an idea of where the fire is, right? North 35 degrees east. So north and east, so up and to the right. All right, so from Station A, the fire is up and to the right, north and east. All right, so I'll draw the fire right there. All right, we're keeping the diagram as simple as we can, right? We're not drawing flames and fires and burning, a dot. A dot is the lookout station. A dot is the fire. Okay. Now, we've talked about bearings. It's been a little while. It's a few videos back, maybe 6 or 7 or 8 videos back. But we did talk about bearings at some point. And the thing with bearings is we're still talking about degrees, 35 degrees. But when we were talking about unit circles, if we said an angle of 35 degrees, we're coming up this way, right? If this is the circle, a 35-degree angle would be up from the positive x-axis. But we're not talking about angles on the unit circle. We're talking about bearings. So north 35 degrees east means from the north, 35 degrees in the direction of east. All right, so if this is the north-south line, we're looking at lookout station A. All right, so there's north and south. Starting at north and rotating 35 degrees to the east. 35 degrees in the direction of east. So starting at the north, going 35 degrees this way. So that red angle is north, 35 degrees east. All right, looking good. And the bearing of the fire from station B is north 30 degrees west. So let's change that to 30. Oh, let's go back to blue. All right, north 30 degrees in the direction of west. Okay, so north and west, so up and to the left. All right, so looking good. So let's finish that. So now we have a triangle. Looking good. Okay, here's our north-south line. All right, with bearings, we always start with the north-south, either from the north or from the south. In this one, it's from the north, rotating 30 degrees in the direction of west. All right, so that's north 30 degrees west. All right, so now we have a nice, as simple as possible, right? A nice, simple diagram. So now we can look at the question. How far to the nearest tenth of a mile? We're going to round to 1 decimal place. So how far, rounded to 1 decimal place, is the fire from each lookout station? All right, so we're looking for this distance right here. The distance from A to the fire, and we're also looking for the distance B to the fire. Right? We've got angle A, we've got angle B. So let's call the other one angle C. Now, like I said, a diagram, if it's drawn correctly and labeled correctly, goes a long way. You want it as simple as possible. So there's a lot on here we don't need. So let's take this and just make a nice, simple triangle. This is A. This is 17. This is B. Right? This will be side A. This would be side B. And this would be angle C. And we're looking for those two missing sides. Now, what about these angles? What about angle A and angle B? Well, if you look right here, we've got a right angle, right? Right here is a right angle. And so part of that right angle is the 35. So the other part, which is going to be angle A, is going to be the complement, meaning those two angles have to add up to 90 degrees. So that means angle A has got to be 55 degrees, because 55 plus 35 will give you 90. All right, and then the same thing, looking over here at angle B, again, we have a right angle right here. So the bearing is 30, and the rest of that angle, again, is going to be the complement. 90 minus 30 will give us 60. But to use the law of sines, we need to know a pair. We either need to know both A's or both B's or both C's, right? We need to know a pair. Right now, we don't. We know angle A, but not side A. We know angle B, but not side B. And we know side C, but not angle C. Not a big deal because this third angle is always easy to find. We don't need trigonometry for that. The three angles of the triangle have to add up to 180. All right, so if we do 180 minus 60 minus 55, whatever's left over is going to be angle C. And in this case, that's going to be 65 degrees. All right, so now it looks like we can use the law of sines. We've got an angle, we've got a side. We've got both of the C's, angle C and side C. Okay, so let's apply the law of sines. The sine of angle C over side C is equal to, well, now we got to find A and B. We got to do it in two steps, so it doesn't matter which one we find first, the A or the B. So I'm just going to go ahead and find A first. So the sine of A over A, and then we'll work with B next. So the sine of angle C, that's 65, divided by side C, that's 17, is equal to the sine of angle A, that's the sine of 55 degrees, over side A. So notice there's only one unknown here, right? The only unknown is little a. All right, and as we did in each of the problems in the previous video, once we set up the law of sines, we could go ahead and cross multiply. Cross multiply. So A times the sine of 65 is equal to 17 times the sine of 55. Now, don't go taking out the calculator right now, right? And plugging in the sine of 65 and figuring that out, and the sine of 55. We're not there yet. It's not time for the calculator just yet. Soon, but not yet. All right, so we want to solve for A. I don't know what the sine of 65 is, but I know it's a number. So we could divide both sides by that number. Sine 65, sine 65. So on the left, they cancel. Sine of 65 over itself is equal to 1. So we get A is equal to 17 times the sine of 55 degrees divided by 65 degrees. And now it's time for the calculator. So let's take all of this and just type it into the calculator. So the first thing you want to do is make sure you're in the right mode. So go to mode, make sure you're in degree mode, because we're looking at degrees here, not radians. Right? And so we'll say 17 sine 55, close parentheses. So that's the numerator. Divide by, oh, I think I said, hold on. I said the sine of 65, but I just wrote 65. Apologies for that. And that's the sine of 65. You gotta make sure we include the sine there. All right, so back to the trusty old TI-84. Divide by sine of 65. All right, and we're rounding to the nearest tenth of a mile, so it looks like 15.4. It looks like 15.4. So let's say A I'm not going to say equal because it's not exact, right? Oop. Sorry about that. We rounded. So I'm going to say, A is approximately, right? Because if you look at the calculator screen, we got 15.36518, dot, 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 dot. So we rounded it to one place. Rounding means changing. So it's not equal. It's approximately equal to 15.4. That's was a 15.4. Let's go ahead and circle that in green. There's our answer. Oh, half of our answer. So the lookout station B, not lookout station A, right? Side A, right? Side A is the distance from lookout station B to the fire. Lookout station B to the fire. Because side A is opposite angle A. Okay, let me switch to a different color because we're going to do everything we just did just one more time. All right, so instead of working with the A and the C, let's just do everything we just did, but we could say sine C over C equals sine of B over B. So that's going to be sine of 65 degrees over 17 is equal to the sine of 60 over B. All right, so we're going to do two things here. First, we worked with the A and the C to solve for A. Now we're working with the B and the C to solve for B. All right, so we'll cross multiply as we did before, basically following the exact same steps. So B times the sine of 65 is equal to 17 times the sine of 60, divide both sides by 65. I'm going a little bit quicker the second time around because we just did this. B is equal to 17 times the sine of 60, all divided by the sine of 65. And now back to the calculator. So we've got 17 times the sine of 60 divided by the sine of 65, and we get rounded to one decimal place. We get about 16.2. Oop. All right, so side B is 16.2. So lookout station A. Lookout station A is about 16.2 miles from the fire. All right, looking good. One more to do. Similar problem, but different as well. Trees in a local park are hundreds of feet tall. The height of one of these trees is represented by H in the figure shown. So in the first problem, we had to create that diagram. In the second one, it's given to us. Sometimes it is, sometimes it isn't. All right, here's the tree, right? Side H, that's the tree. So we want to eventually find the height of the tree. That's part B of the problem. Part B says, find the height of the tree, right? That's part B. So let's look at part A first. Use the measurement shown to find A. Right, so we're looking for first side A. So use the measurement shown to find A to the nearest tenth of a foot in the oblique triangle ABC. Oblique just means there's one angle. There's one angle that's bigger than 90 degrees. Okay, so we're looking for A. So we're looking at that blue triangle. We're looking at that blue triangle. So that's 400. That's angle A. That's angle B. So this is all labeled. I'm just looking at this blue one right here, right? This is angle C up here. So this is side A. That's what we're looking for. This is side B. This is given as 15 degrees. So we have one side and one angle. It's not enough information. We need something else. And we actually have something else because this angle right here is 180, right? This red angle, that's 180 degrees. That's 180 degrees. So if part of that is 25, so here is 25, so the rest is angle B. So angle B is going to be 180. Take away the 25, right? 180 minus 25. So that's going to be 155. So that's angle B up here, 155. And just like in the last problem, if we have two of the angles, that's enough to quickly get the third angle. So angle A and B, right, 15 and 155, that's a total of 170. That's a total of 170 degrees. So that means angle C has got to be 10, right? Because they have to add up to 180. 155 plus 15, that's 170. Plus 10 will give you 180. All right, so now we've got our triangle. We know all three angles. We know one of the sides. And what we want to do is figure out side A. All right, so law of sines. We could use law of sines again. So we have angle B, but we don't have side C. Or we have angle B, but not side B. But we do have both of the C's. This is side C. This is angle C. And so we have both of the C's. So we could say the sine of C over side C is equal to the sine of A over side A. So that would be the sine of 10 degrees, that's angle C, divided by side C, which is 400, is equal to the sine of angle A, and that's 15 degrees, divided by side A. All right, we've got the law of sines. We could cross multiply to remove those fractions. So we got A times the sine of 10 is equal to 400 times the sine of 15. Right? A is being multiplied by the sine of 10, so let's divide. So we could cancel that off. So we got sine of 10, top and bottom, they cancel. Whatever you do to the left, we've got to do to the right. All right, so we got A is equal to 400 times the sine of 15 degrees, all divided by the sine of 10 degrees. And now this, we're going to round it. to the nearest tenth of a foot. So this is a job for the calculator. All right, so we got 400 sine 15. I don't need the degree symbol because I'm in degree mode. So everything's the way it should be. So we got 400 sine 15 divide by the sine of 10, and that should do it. 596 and change. We'll round it to one place, so that's 596.2. 596.2. All right, our goal, or our overall goal here with this problem is to solve for the height of the tree, right? But what do we have now? We've got a right triangle. We've got a right triangle. We don't need the law of sines for a right triangle, right? The law of sines is only for when we don't have a right triangle, when there's no right angle, right? For the right triangles, we have our definitions. We got sine theta, cosine theta, and tangent theta, and we define these guys on the right triangle. The sine of an angle, well, here's an angle right there. We're going to use 25 as our angle. The sine of an angle is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of the angle is the length of the adjacent side divided by the length of the hypotenuse. And the tangent is the length of the opposite side divided by the length of the adjacent side. All right, so these are our definitions, our right triangle definitions of the six trig functions. Well, we now know from part A that this side is 596.2. So we have an angle. We have a hypotenuse. And we're looking for an opposite side. So we've got angle, hypotenuse, and opposite. And the only one of those definitions that relates those three to each other is the sine function. All right, I'm going to erase this guy because we're done with that. That was part A. So now for part B, we're looking for H. So we could say the sine of 25 degrees is equal to opposite over hypotenuse. Opposite over hypotenuse. We want to solve for H. We can multiply both sides of this equation by 596.2. And now we could solve for H to the nearest tenth of a foot. So that's going to be 596.2 times the sine of 25 degrees. And that should do it. So we got 251.9650076. If we round this to one decimal place, that's actually going to round up to 252.0. So I'm just going to go ahead and say 252 feet. All right, and that should do it for this problem. This is part B. This is part A. A and B. So these are two problems. There's a whole lot of, variation in the way these problems could be given. Um, if you're not sure how to start a problem, like I said earlier in the video, best thing to do is just start sketching it out, labeling what you know, see what you're working with, see what's unknown, and then hopefully things start becoming a little bit more clear. Alrighty, that is it for now. That's it for this video. I hope this was helpful.